Welcome back to another M&S tutoring video, and in this video I'm going to be showing you a more difficult word problem related to a real-life revenue application. This word problem involves the knowledge of factoring and quadratic, so if you haven't watched my previous videos, please go watch those before you actually see me solving this problem. So let's get started on solving this revenue application. First of all, let's read this problem and highlight the important things that we need to solve this problem. A bowling alley charges $5 and gets on average 400 customers weekly. For every increase in price by $0.5, there were 25 less people. If the bowling alley made $10,437 that week, how much did they charge per customer? Well, the main important things in this problem are that initially they charge $5 and get on average 400 customers, and for every increase in price by 0.5 there were 25 less people and they made 10,437 that week. Okay, so let's get started. What you always want to do when you're looking at real-life revenue application questions is you want to allot one bracket for the price. So the price bracket in this case would have first the original price, so original price, and then it would have how much the price changed by. So we know that the price changes by 0.5, so we would write 0.5. But we don't know how many times it changed, so we would write x in this case. And just like that, we would define our variable x. And x would be the number of times the price, the initial price, increase. Right? So after we have the set price bracket, we have to allot one bracket for the amount of customers or amount of people there are at the bowling alley itself. So the customer bracket would look something like this. It would have the original amount of people plus, or sorry, in this case it would be minus how many people would decrease for every increase in price, right? So as it says, there would be 25 less people for every $0.5 increase. So that's why I wrote negative 25x. Now we have to set it up as a quadratic equation in a factored form with both these brackets beside each other so we can solve it. So let's look at it. The original price was $5. So we can say 5 plus 0.5x multiplied by the original customers, which was 400 minus 25x is equal to 10,437. After we have set up this equation, we're going to go on to solving this equation by expanding the bracket below. So we're going to write this equation as a more simplified term as we can expand it to a more quadratic equation form. So we can write, let's say in this case it would be 0.5 times negative 25. It'd be negative 12.5 x squared. And then we'd have to expand the 0.5x into the 400 as well. So 0.5 times 400 would be 200. So 200x. And now we have to expand the 5 into the negative 25x. So negative 25 times 5. So it'd be minus 125x. And then we have to expand it into the 400, sorry. So it's 400 times 5, which is 2,000. And we have to remember that this 10,437 is still on the other side. And now we can go on to simplify the left side of the equation to get negative 12.5x squared. And 200 minus 125 is equal to 75, so plus 75x plus 2,000 minus 10,437 is equal to 0. So 2,000 minus 10,437 is equal to negative 8,437. So this can be simplified even further, as we can write 12.5x squared. This is a really long equation, plus 75x minus 8,437. Now all we have to do is we have to plug it into the formula, the quadratic formula, and we can have an answer for x. And the answer for x will not be the answer for the problem. Remember, it says how much did they charge per customer, but x is how many times the price increased. So after we solve for x using the quadratic formula, we have to multiply it by 0.5. So we have to multiply x times 0.5 to get the answer of how much money they charged. So that's the end of the video, guys. I hope you learned something new. If you have any comments or concerns, please feel free to leave it down in the comments below. And thanks for watching, guys.